GitHub is an entire site that the program can post, like LinkedIn for programmers.
So what was the quiz question?
Difference between Git and GitHub.
How are we going to let him write an answer?
If he writes it in the next 30 seconds.
No, flip to mine, read that one, it'll give them longer. My brain's not on.
Does that say cheese? Is that cheese?
Taste it. Does it taste like cheese?
You write it?
Oh, that's what I was for. Yeah, for 300. What is it? Where would we use DTF?
No, this is for.
Oh,
I don't know what it was for.
yeah. Oh, that's for Q.
for
We
Q.
use D to F in towers.
I think we use D2 return. But then
Yeah, then it's it.
well, I typed a couple of things. Okay, so I mistyped it and then I replaced it. So what's the so Git is a tool for managing a local. Well, Git is a client-side tool for managing a repository. GitHub is a repository. So GitHub is a repository that happens to be located on the internet that you could you can use Git, the Git protocol, to push your code up to. Where Git itself is a protocol and typically it's used for connecting to a local repository that it creates for you. All right, so you might say Git is the client. GitHub is a server for storing the stuff that Git controls. All right, so for your homework, you were supposed to modify our current server to act as an echo server, right? And then ultimately push your stuff up to GitHub so that you could submit it and I'd be able to see it on there. So the idea here is let's just bring that up to snuff right here so that way we can create our next step. I'm just going to fix this real quick. All right, so in our server, we're going to create a server socket. This guy's we'll keep track of how many counts we have. Forever, we're going to have an incoming, we're going to say we're waiting, select an incoming connection, spawn off a response thread, say we're connected, and then tell that response thread to start, and then we'll listen again. So that's all this guy does in here. The response thread, this is the guy that's doing a whole bunch more. So we're going to take out all this HTML crap we had in here. When we create a response thread, we'll take in a socket. We'll store that socket as the local socket. Then run, which is the method that automatically gets called when we hit start. That's because this guy extends thread, is going to create a scanner for reading in from that socket. It's going to read in a line, spit stuff out, blah, blah, blah. So you're just supposed to do an echo server. Which means this. So whatever it reads in, it spits right back out. So we're going to just throw this guy in a loop. Okay, that makes sense? So this is our echo server. Every thread's just going to sit here and forever, it will read something in from the user and then spit it right back out. Except right now, it's spitting it out to the screen here on the server. We actually want it to print out to the client. So the client's going to write something to the server's going to send it back to the client's going to spit it out. All right, so we need to not just have a scanner, but we're going to have a print writer. And we'll build this guy with the output stream. So instead of printing out to the screen, we'll say output dot println req, and then output dot flush. Make sense? You might think of these two things if you've ever been to a bank that has the, the tube things outside. So when we print it, we put the tube into the machine, and then flush is when we push the button, it actually sends it. Make sense? So that's kind of what's happening there. Sometimes, actually, I think print writers might have a second constructor where we can pass it a true, and that does auto flush. I'm actually interested now, because I really like saying auto flush. That would be in java.io, print writer. Haha, look at that. Output stream, auto flush. That's such a good variable name. All right, so we'll just use that version of it. We'll set this to true for auto flush, then we don't have to manually flush. It's like the upgraded toilets. Now all the toilets in the bathroom, right? When you leave, they flush on their own, right? That way you don't flush anymore.
That way you really didn't never wash.
You know what I'm saying? It's like, what do you mean we have a bucket? That's what we have, is a bucket.
If we were happy people.
All right. So in any case, this is what the server will do. It'll take an incoming connection, spawn off a thread. The thread will create a way to read in and a way to write out to that socket connection. And then forever, it'll read something in, then write it right back to them over and over and over again. Okay, so that's what this server does currently. I'll go ahead and run this. And, well, here, I'll open up my terminal. What's the, is this 1234?
Yep.
Telnet, localhost 1234. So I'll say blah. Blah came right back. Woot came right back, so on and so forth. If any of you guys want to connect to it, connect to IP address 172.31.236.127 at port 1234, and it should be an echo server for you as well. I told you guys about that trick on the Mac, right?
Yeah.
You can hit hold Option when you click on your Wi-Fi up there. It'll give you all this extra information.
Show you everything in existence. I'm going to show you when we move
I haven't had anybody else connect. None of you want to connect to my Echo server? It's pretty dark.
It's just I move like I have 8 of those lights.
No, nobody else is connecting? Oh, there we go. We got a connection. So you should be able to do Echo stuff. And my guy's still echoing, so on and so forth. All right, so my guy supports, and you're connected. It's echoing to you. Who's connected?
What's the
It's not me.
Echoing to you?
I'm trying to get in.
You're trying.
Something else.
I'm trying to get in, but I'm doing something else. What does that even mean? All right, so that's what you needed to do for homework. Let's create that kind of setup. Would you just get in?
No, I was trying to find my project.
Oh,
It got.
You tried to do it.
all right. I just killed my server, so you just got disconnected.
It's okay. He was trying to do it.
So everybody who was connected just got connection closed by foreign host. Well, are you trying to do something interesting?
No. Trying to participate.
It was a denial of service attack.
Well, that would have been all right. Here, we can run that again.
No, it's not working. Getting there. I have to debug it.
You have to debug it.
Yeah, I did.
Try again on Monday.
Were you just writing a, creating a bunch of sockets to connect to it all at the same time?
Yeah.
Works out. Here, we'll rate that real quick. Kill.java.
What was that IC?
Oh, I think that's what it is. I'll just get a connection to a random person.
Right, somebody disconnected.
Good thing Acton in this class he would be able to follow along.
Oh, it doesn't print on yours? That's no fun anymore.
Yeah, I think it's pretty good that I took out the local echo. So we'll say blah is equal to a new socket. What's the IP? 7230. Oh, I guess it'll work as localhost on here. 1, 2, 3, 4. What is it? Blah.connect. See, this is gonna. What is our socket? Is it open?
So will it kill your server if I just hold down the Enter key and keep sending stuff to it?
Oh, I think it connects on its own. I don't actually have to.
Yeah, I think you did, yeah. Can we do this with our client?
Yeah, but now we're crashing our own. It's far more exciting.
Mm-hmm.
All right, so this should just be out of memory. Killed it. It didn't take very long to kill it either. So
You killed the connection to you.
there's an example of a denial of service attack. So, all right.
What you read?
All right. So in any case, what do we want to do now? We want to have two connections come in, and we want to connect those two guys so now that they can kind of do a chat. We're eventually going to be sending files across these, but initially what we want to do is we want to use the server as a middleman so that maybe you two can chat with each other. That make sense? So maybe any two people can chat with each other. So what I'll do is we'll have our response thread do this. Actually, let's just do the example out here once. So we'll have our server socket, and we'll say for int I is equal to 0, I is less than 2, I plus plus, because I don't want to solve too much of the problem. We'll get an we'll get an incoming connection. Then we'll get our incoming connection. We'll create our response thread, passing that socket, and then we'll come back and listen a second time. So right now my server's only going to allow, the first two people to connect. All right. Once two people have connected, we need to connect those two guys together. So we're going to have one thread. So I'm going to actually say response thread up here. We'll put that outside of the loop. And we'll start this guy off at null. Then after we get a connection, we'll ask the question, if RT is equal to null, then we'll actually create our response thread and start it. And say connected. Otherwise, that must be the second connection, right? Second connection, we need to add this guy to our response thread. All right, so we're going to have to teach our response thread another method for him to get connected. So inside of a response thread, we're going to have a method public void add. We'll say add client. And this will take in a socket S. Okay, and we'll go ahead and call it out from main so we don't forget. So we'll say rt.add client connection. So first time through, we'll build a new thread using our connection. Second connection we get, we're just going to add that connection to our client. Okay. Now, what we're going to do here is inside of our client, we're currently creating our input streams and stuff like that. But what we really want to happen is we need to have, we're going to call this guy, well, we'll say S and S2. It's good enough, I guess. Socket S2 for this little example. So we'll say this dot S2 is equal to S. Okay. Do what I want it to do. That doesn't matter. All right, so when we first create our response thread, we're going to say this dot S2 is equal to null, even though that's going to be assumed. And then when we say run, when we tell that first thread to start, what we could do is we could have a loop that says while this dot S2 is not equal to null, or y is equal to null, we may say something like waiting for the second connection. We're going to do this a couple different ways. This is kind of the bad way of doing it. All right, so this guy's just going to keep spinning. Has there been a second connection? 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 Over and over and over and over again. All right, as soon as there has been a second connection, that is, we've called this add client method on this guy, then this guy will be able to continue on. And what are we going to do down here? Well, we want these two guys to talk to each other. So right now, my input is coming from S's input stream. So I need, maybe I call this guy S input. And then I call this guy S2 input. And he's going to get the input stream associated with S2. And then we have our S output. And then our S2 output. All right, and then we're going to say whoever connects first gets to talk first, because we're showing that there's going to be a problem where now we have to go back and forth, back and forth, back and forth. So the initial communication will be S2 output dot println, S input dot next line. And then the second thing will be S output and S2 input. So the first time through, we're going to wait for S, the first guy who connected, to send something. We will then write it out to S2, the second guy who connected, so it'll show up on his screen. Then we will wait for S2 to write something back, and we'll write it out to S. And before either of those happens, just so the two people know that they're connected, we'll say S output dot println connected, your turn. Oh, actually, let's do it this way. We'll say connected to both of them. So we'll write out connected to both of them so you know you're actually connected to the server. And then we'll say your turn. I think that should still print out. We'll just do Lynn just for now. It's not we're gonna change this anyways. So the very first time we're telling the first guy S that it's his turn. The second time we'll tell S2 that it's his turn. So we can go back and forth. But in between there, you should see the echo back out. All right, so maybe we put a little string in here from S. Something like that. And this one is from S2. All right, so this just allows the two people who are connected to go back and forth, back and forth, back and forth. Now, in this assumption, this server that I have running here is a guy that's reachable from anywhere on the internet, even though we're here on campus, so it's only going to work if you're on the campus network. So if you guys were at your home internet, your cable modem or DSL, whatever, even if you're behind a firewall, you could both reach my machine because I'm not behind a firewall. And then I'm going to connect those two together so that you guys can talk to each other. So we're modeling this this idea. All right, so out here in driver, we have our we're going to have our server socket. We're not even using count right now, so here, I'll just take it out. Create a response thread once. We're going to go through 2 times. We're going to say we're waiting, accept an incoming connection. If it's the first connection, create our response thread, tell it to start. What does the start method do right off the bat? It sits here and this while loop basically says, wait for the second connection. That's what that guy says. Wait for the second connection. Then this guy spins back around. He waits for the second connection comes in. RT is not equal to null because you already created it last time. Then we say add client to that guy.
Do we need the flush socket?
Flush socket.
The original wasn't there like s.flush?
No, because I used the other version of the constructor.
Oh.
The one that takes in the Boolean auto flush. Huh?
Right.
Auto flush? Yeah, we used auto flush. All right, so we're going to go ahead. I'm going to start my server up. We have 2 volunteers for connecting. You're connecting? Okay, well then I'm definitely not going to connect on localhost. Who else is? Are you connecting?
I can connect.
All right, so let's have those 2 connect. So I'll go ahead and run it. All right, somebody connected.
I connected.
All right, now it's waiting for the second connection.
Typing in your IP. I did this earlier. It worked.
Well, why don't you connect? Since they suck.
Putting in local host and
172, 31, 236, 127. All right. Did you get connected?
I did.
Oh, you did?
Yeah.
You're connected too?
I can't type.
I thought you were connected. We can't have three guys connected. All right, so somebody right now, it says your turn on their screen. Who's that? Is that,
I have a your turn.
who else has a your turn?
Mine said connecting, ... Oh, it said failed.
Oh, okay, so just these two. Okay, so it's your turn. So go ahead and type something. And then you tell me what he typed as long as it's classroom appropriate.
Testing.
Testing, okay. Now you type something back.
I got hello like as soon as I hit enter.
If you type in
now it's back
multiple
to my
things,
turn.
it will
It'll
things.
store it up, right?
Okay.
So then there was some bleeps.
Actually no, not yet.
Follow. All right, and now you're able to write something back, right?
Goats.
I like goats.
I like goats. I'm high, getting closer.
Okay, so we have multiple connections now, right? So this supports two. What if we wanted to do more of a global chat room? How would that work? Right now, the way we have this working here, I'm gonna cut you guys off. So you're dead.
I was having fun.
Okay. Well, so first of all, we just solved the firewall problem, right? We just wrote right here, as long as my machine's not behind a firewall and my IP address is reachable, it does not matter where you guys are as long as you're on the internet. Okay, you could both be behind 7 firewalls. Okay, Fort Knox, you name it. Okay, now, but now I want to make more of a public type chat room where it's just a constant thing coming in. Now, how is that going to work? How do I allow multiple people to keep connecting? Right now, I'm forcing it to just 2. And I'm working off the knowledge that, okay, I know one person's connecting. I'm just going to wait for the other guy to finish connecting. Wait for the other guy. Then as soon as he connects, then what happens? Yeah, I'm done. Okay, well, what if we wanted to add a third person to the mix? Well, using our current model, I would have to make the first 2 people wait until a third person finally connects. But realistically, shouldn't the first 2 people be able to talk to each other until the third person gets in there? How would we pull that off?
Well, not with the iCloud.
This is not, definitely not with iCloud.
I made something different. Like the driver, I wrote him like the server. So he hold a list, a static list of all the opened sockets.
Okay.
Each time someone connects, you add in that list,
Okay.
and you have a static method that you can broadcast a message from whoever wants. So inside the response thread, I can reach the list of the sockets. So it's almost like the first version we made before, and instead of writing in that output, you send to the...
Right, so what you're doing is when you build your response thread, you're not passing it a socket, you're passing it the pointer to the list.
No, the connection. The list is only visible for the driver.
Okay. All right, tell me more about yours. So you're going to create a static list here.
Yes.
So I'll do that first. So we're going to do a static linked list of sockets. We, in the end, might not want to make it a linked list of sockets, but for right.
Actually, it's not the socket itself, it's the response thread.
Oh, you're going to create a linked list of the threads.
Yeah, but Actually, I didn't do like the thread. I create a runnable, an implementation.
Yeah.
So it's
Okay. I get what you're doing. I think that this might be a better solution that uses pointers. But actually, you made your own runnable, so you're actually probably doing the exact same thing I'm about to do. Is my guess. You tell me if that's the case. So I'm going to create a new class. We're going to call this guy connected client. Okay, connected client is going to have a private socket, the socket. And this is java.net. Then we'll have a public constructor. That takes in that. And we will say this dot the socket is equal to the socket. All right, but we're also going to want to have some other things up here. The ability to read from and the ability to write to that socket. So we're going to have a private print writer called output, and we'll have a private scanner called input. So we'll import java.io print writer and import java.util scanner. And then we'll go ahead and build those objects in here. So we'll throw this inside of a try just to keep it relatively compartmentalized in here. All right, so we're going to say this dot output is equal to a new scanner built using this dot the socket dot get. Output is the print writer. Get output string. And then true for auto flush. Abe?
Thank you.
the writer.
Oh, I said new scanner. This is supposed to be print writer. And then we'll say this dot input is equal to a new scanner. This dot the socket dot get input stream. All right, so this is all inside of our little connected client thing. So when we first get a client connection, we're going to create an instance of connected client, and connected client's going to take in the socket, and it's going to set up these three variables. Just set the socket so we have access to it in case we need it, and then set up the way to do input and a way to do output. All right, and then I'll catch the exception, which I'm sure will never happen. All right, then we're going to have a public send message. And what this guy will do, public void, sorry. Okay, this guy will say this dot output dot println message. And then we'll have a public string get message that returns this dot input dot next line. So we'll just keep it simple like that for right now. Okay, so this is our connected client class. Now what we'll do is out here in driver, we're going to have a linked list of connected clients. All right, we need to import java.util. Okay. And then in our main method, when we have an incoming connection, what we're going to do is we're going to, I'm going to forget about this. Well, we'll come back to the response thread here in a second. We're going to say driver.theclients.add new connected client built out of our connection. Okay, so every single time we have a new socket connection that came in, we'll go ahead and build a brand new instance of connected client, and add that to our list. Now we're probably going to want to store that in a variable because we're going to need that pointer again here in a second. So we'll store it inside of a variable called CC. Then we'll add CC to our, well, we might need it again. Actually, right now, I think I might not, but it's fine. So we'll add CC to our linked list. So now we have a giant linked list. Okay. Actually, I changed my mind. We will need it. Okay, so now we're down to our response thread. I'm going to bring that back into the mix here. So we accepted our incoming connection. We created an instance of connected client, which has nothing to do with threads. It's just a container for holding a socket and building the way to get something, from and write something to that socket. Then I'm going to say, I'm going to rewrite my response thread to no longer take in sockets. Now it takes in a connected client, the client. All right, we'll get rid of this add client crap. We'll get rid of this busy wait crap. We'll get rid of all this crap. Good. All right. So back out here in driver, when we create our, so we're going to say, what did I say, response. Response thread. Am I spelling that right? No, I'm not spelling it right. We'll also pass that guy to our response thread. Now, response thread is going to actually take in another value as well. Right now, it just knows about connected clients. I'm also going to send it a linked list. Let's call this all the clients. So it'll take two parameters, a linked list, all the clients. We'll set this dot, all the clients equal to all the clients. Okay. So now our response thread knows about the particular client he's in charge of, and it also knows about the full list of all the clients. So inside here, when we create that response thread, we're going to pass it CC, and we're also going to pass it the clients, which is a static method that contains all of the clients that have come into our system. That make sense? Go ahead.
Since it's static, can't we call it just straight from connected client?
You could. You could say driver dot. You could. Absolutely. So you might even say that. You might say it's actually even probably better than passing pointers around. You wouldn't do it from, well, you could do it from connected client, but I think what you mean is response thread.
Yeah.
So why have a pointer to this when we could just access it by saying driver dot the clients, which is true. So we won't have it taken that parameter there. I do like this though. I'm gonna have this local guy here just for the sake of not forgetting about the variable. So I'll say all the clients is equal to driver dot the clients. So that's where the link is actually created. So I'll have a little local variable here called all the clients that is my reminder that I have a linked list someplace else. That way I don't just assume that I know about it down here. So one extra variable is not going to kill anybody. Now I don't need to pass it the pointer here. So we can just grab it globally. All right, so we're going to wait for incoming connection. We're going to accept that connection. We'll create a new connected client from that connection. We'll add that connected client to our global list of clients. Then we'll create a new response thread passing it that connected client and tell that response thread to go. rt.start. Okay, so we have that guy going now. And now what we'll do, just real quick in our final minute, we'll just make it kind of an echo server for a few minutes. I need to go into driver, not driver, response thread, and run. We'll just say while true, string message is equal to cc dot the client. Get message. So we'll read in a message from the client. Then we'll say for client connection cc in all the clients. Oh, connected client. Sorry. In all the clients. And this is a linked list of connected client up there. We'll say cc dot send message message. So he'll even spit it back to himself now as well. So now every single connection that comes in, we'll create a response thread. The response thread will just sit there and forever, he'll read in from the user and then echo out to everybody else, including himself. All right, so if I start the server running now, we should all be able to connect. There's many people who want to try to connect. And we can say stuff and other things should spit out to the screen. I haven't seen anything yet. I'm very afraid actually now. All right, well, in any case, we're out of time. So we'll come back next class and we will figure out why this isn't working.
Oh, come on, I was having fun.
Okay, we'll figure out why this, was any of you guys getting stuff back and forth?
Yeah.
Huh?
Who wants to kill the goat?
You were
Not
getting,
a nice
you were getting
goat.
stuff back?
Yeah,
Okay,
and
so we must be doing something that's blocking. Doesn't matter, we're rushing at the end. So we'll look at this on Monday. See you then.